Okay, welcome to the lesson on simplifying algebraic expressions. Okay, this can be found in your book on page 387. Let me write that. Page 387. And also page 388. Most of this can be found on both pages. Okay, so some of the things that we have here. Remember, when you're taking notes, don't forget a title. Essential question: how can you use numbers and symbols to represent mathematical ideas? So we're using symbols meaning variables, and of course numbers being numbers. The vocabulary today is term, like term, constant, simplest form. Okay, so some things here. When addition or subtraction signs separate an algebraic expression into parts, each part is called a term. So when I look at these, here's my expression here. All of these are terms. Negative 4x is a term. Positive 12, or just 12, is a term. X is a term. So when I see this expression here, I have three terms. Okay, like terms contain the same variables to the same powers. So usually we're looking for things that are the same or like. So in this case, I have two like terms because they both have the same variable, x and x. So it's the same. And then a constant is a term without a variable. So we have one constant here, and it's by itself. Sometimes our expressions have multiple constant numbers. Those can be considered like terms also. So like terms are both ones that have the same variable or constant numbers that do not. Okay, and then in simplest form is when we have taken our expression and we have no more like terms and all of the parentheses are gone. That's what simplest form is. So most of the time in our problems in this lesson is we're trying to get to simplest form for our answer. So that's usually going to be our answer or the result of simplifying. Okay, so let's get into a problem to see what these problems are going to look like. Yeah, they're going to be expressions. They're going to look like this. So if you look at number one, and number one, we have, it says identify all the terms, like terms, coefficients, and constants in the expression. So some of these we've had before, like coefficient. And then some of these are new terms that we have not. So the first thing we're going to do is we're just going to label, okay, terms, and have all of these terms. I have 6n, I have negative 7n, I have negative 4, and I have n. So I'm just going to write that out. I have 6n, that's a term. I have negative 7n. I have negative 4. And I have n. Okay, I'll put a comma in between each one of these. So that lets me know. Okay, they want to know like terms. Well, once you already have the terms out, we can look at these and say which ones are like. Well, the ones that are like are the ones that have the same variable. So I have an n, I have an n, and I have an n. That's the only variable I got. And they're all the same. So really I have three like terms. I have 6n, negative 7n, and n. Okay, so now I have to figure out, well, what are my coefficients? And if you remember what a coefficient is, it's a number next to a variable. And so I have, you could say you have 3, but I'm going to list it as 2. I have a 6, and I have a negative 7. You can say that that's 1, because it's 1n. So you could say that that's 1, if you choose to. Either way, as long as you know that these are numbers next to variables is our coefficient. And then we have constants. Those are those numbers or those terms that do not have a variable. And we have 1, which is a -4. So now, at this particular point in time in the video, what you're going to do is you are going to do this problem here and then answer it within the video. Hi, welcome back. So what we're going to do now is we are going to take this problem and simplify it. We're going to take this expression and we're going to simplify it. We have 4y plus y. And the way we're going to do that is we are going to combine like terms. There's only 2 terms. So we're going to combine all of the like terms. There's only 2, and they're both like because they both have a y. Now, like I told you before, we look at the coefficient, and the coefficient here is 1y. They just don't put it. When you only have 1y, they don't put it because it's 1 times y, which is just y. This is 4 times y, which is, we don't know what y is yet, and we're probably not going to know what y is in this problem. So our answer is going to include the 1 plus the 4. So we're going to combine all of these. Another way to look at it is we have y, 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 and y. And then over here we only had 1y, and we add them all up, and we have a total of 5 y's. 4 plus 1 is 5. That becomes our simplified expression. And remember, it's in simplest form when we have no more like terms and we have no parentheses. Let's look at another one. Now we have a nice long particular expression. 7x minus 2 minus 7x plus 6. So what I'm going to do here is I am going to identify the terms that are like using different colors. So I'm going to look at my variables first. I have a 7x and I have a negative 7x. Okay, remember the negatives and positives always go in front of the number. But then I have some constant numbers. I have a negative 2 and a 6. So there's 2 things that I'm doing here. The first thing I'm going to do is I'm going to combine like terms. In other words, I'm going to combine 7x plus a negative 7x. That was my, oops, that was my green. Well, 7 plus a negative 7 is what? That equals 0. So all I have left now is a negative 2 plus 6. We're combining. That means to add. That's why we added each term. Each term. Okay? This was the color pinkish. Negative 2 plus 6. What does that give us? Well, if you remember your negatives, that's going to give you a positive 4. And that ends up being my answer. In this case, in this simplest form answer, you are going to get the answer of 4. Okay, so what you're going to do right now, you're going to do the same thing. You're going to write this expression here in simplest form.